Hi guys, this is Jonathan Lambert with Maths and Stats, and in this video, another video in our series of videos dealing with calculus and in particular differentiation from first principles. And a particular example, we're going to present the derivation of the derivative of the natural log. Okay, so let's just get straight into this. There's a little bit of work involved in this, but it is straightforward enough. So let's just define the natural log as a function. Let's just say let the f of x, okay, be equal to the natural log of x. Okay? And we know the definition, we know what the definition of a derivative is with respect to limits. So from the definition, okay, of a derivative, okay, from the definition of a derivative, we have that its derivative, the derivative of this particular function, f prime of x, has to be equal to the limit of the function plus h, we evaluate that x plus h, minus f of x, all over h, as h tends to 0. And that's our definition of a derivative with respect to, in relation to limits. So in our situation, we have f of x is actually the natural log function. So what we're going to do is we're going to evaluate f of x at x plus h and see what we get. So therefore we have that f prime of x must be equal to the limit of f of x plus h. But f of x plus h, f of x evaluate at x plus h is simply the natural logarithm evaluate at x plus h. So it's the ln of x plus h minus f of x, which is just the ln of x, which all needs to be divided by h, as h tends to 0. Okay. Now we know the properties of logarithms, where we have, let's say, the natural logarithm of a minus the natural logarithm of b is the same as the natural logarithm of a over b. So what we can do is we can recombine these two natural logarithms into the natural logarithm of a quotient. But also we can take the h outside here. So maybe we'll actually just do that to make this a little bit tighter. So therefore we have f prime of x is equal to the limit of it's 1 over h times this numerator, the natural logarithms of x plus h minus the natural logarithm of x. Okay, as h tends to 0. So once again, now what we're going to do, we're going to apply this particular identity, that the difference between two natural logarithms is the same as the natural logarithm of the quotient. Okay? So this becomes, therefore, we have f prime of x must be equal to the limit of 1 over h times, this thing here now becomes the natural logarithm of x plus h all over x, as h tends to 0. Okay? And what we'll do here is we'll just divide the x into both of these terms. So we'll split this out. Instead of having the common denominator here, we'll split the common denominator across both of them. So this becomes, let's maybe just note that here, that x plus h over x is the same as x over x plus h over x, which is the same as 1 plus h over x. Okay, so let's just keep that in mind. So actually this thing here is the same as 1 plus h over x. Okay, so now what we have is, so therefore we have that the derivative of f of x is equal to the limit of 1 over h times the natural logarithm of x plus h over x is effectively 1 plus h over x. So 1 plus h over x, as h tends to 0. Okay. And also, let's just keep in mind that the natural logarithm also, let's just recall another property of logarithms is that the ln of a to the b is the same as b times the ln of a. So if we have an exponent, we can pull the exponent down and create a product of the exponent with the natural logarithm. So what we're going to do here is that we're going to reverse the process. What we have effectively here